Think our current technology is advanced? You haven't seen anything yet. Across multiple fronts, a seismic shift is quietly underway, redefining the limits of what's possible. This is an incremental change. It's a full-scale reimagining of energy, connectivity, and automation. The catalyst? A concentrated wave of China innovation breakthroughs that are solving global-scale problems with radical, on-the-ground solutions. We're moving from science fiction to industrial fact at a breathtaking pace. To make sure you never miss a detail of this tech revolution, subscribe and tap that notification bell. Let's get started. Forget everything you know about data centers. Imagine a supercomputer hidden inside a mountain that is now real. Engineers have launched a brilliant cavern-based computing hub. It sits within a hydropower station's tunnels. The location is key. The air inside stays naturally cold and dry. This simple fact changes everything. It means the machines need far less power for cooling. They tap into clean hydro and solar energy right on site. This fusion of natural cooling and green power is a masterstroke. It slashes energy waste. The system's efficiency rating is incredibly low. For every bit of power used, most goes to pure computing. Very little is lost. This project perfectly marries raw computing power with environmental sense. It is a flagship example of modern infrastructure thinking. The setup already rivals millions of home computers. It proves that sustainable development and high tech can be one. This is a powerful China innovation breakthrough. What if the internet came from the stars? For many remote villages, that idea is no longer science fiction. It is becoming daily reality. A bold global project is now using a large constellation of low Earth orbit satellites to deliver fast internet access to places long ignored by traditional low Earths. These satellites fly much closer to Earth than older systems. Because of this, data travels a shorter distance, signals arrive faster, delays drop sharply, reliability improves. For decades, fiber cables and cell towers defined connectivity. Yet these systems struggle in hard terrain. Mountains block signals, oceans raise costs, sparse populations reduce profit. As a result, isolated islands, rural farms, desert towns, and highland communities remain offline. This gap is known as the digital divide. It limits education, healthcare, and economic growth. The new satellite network aims to close that gap. The technology works in a simple way. Hundreds, then thousands of small satellites circle the planet in coordinated paths. Together, they form a moving web of coverage. When one satellite passes overhead, it connects directly with a user terminal on the ground. That terminal is compact and easy to install. No deep trenches, no tall towers, no long cables. Users only need a clear view of the sky. Because the satellites orbit at low altitude, performance improves. Latency drops to levels close to ground-based broadband. Video calls feel natural. Online classes run smoothly. Cloud tools respond in real time. This matters for people who depend on stable connections, not just basic access. Farmers can track weather data. Students can join virtual classrooms. Clinics can consult doctors in distant cities. Cost is another key factor. The company behind the system designs its satellites for mass production. Each unit is smaller and lighter than traditional spacecraft. Launches carry many satellites at once. Reusable rockets further reduce expenses. These choices lower the overall price of service. For end users, this means internet access becomes realistic, not a luxury. Early trials already show results. Several countries have begun testing the service in remote regions. Schools report improved attendance in online lessons. Small businesses gain access to digital markets. Emergency teams use the network during disasters when ground infrastructure fails. These tests prove the model works beyond theory. The impact goes beyond convenience. Reliable connectivity reshapes opportunity. Distance learning allows children to study without leaving their communities. Remote medicine brings expert advice to small clinics. Entrepreneurs can sell products online and manage digital payments. Local economies grow stronger when information flows freely. The system also adds resilience. Natural disasters often destroy cables and towers. Satellites stay above the chaos. They can restore communication within hours. This ability saves lives during storms, earthquakes, and floods. For governments and aid groups, this makes the network a critical backup tool. Some concerns remain. Space congestion increases as more satellites launch. Operators must manage debris and avoid collisions. Light pollution worries astronomers. Regulations differ across borders. These challenges require careful planning and global cooperation. Still, progress continues as standards improve and technology evolves. This project is more than a technical upgrade. It represents a shift in how humanity shares knowledge. The sky becomes infrastructure. Space turns into a bridge rather than a barrier. For communities once cut off by geography, the future feels closer. This is not just a network, it is a lifeline built above the Earth. It connects classrooms, clinics, and markets. It gives remote voices a place online. By turning satellites into tools of access, the project transforms inclusion from a promise into practice. A new era of energy has begun in a major economic zone. The first fuel load has started at a new nuclear plant. This is a monumental step. The plant uses a fully homegrown third-generation reactor design. This technology is a source of national pride and engineering prowess. It represents a key strategic achievement. The location is critical. It will supply vast amounts of clean, stable power to one of the world's most vibrant urban areas. This supports continuous growth without the pollution of traditional fuels. The project highlights a deep commitment to energy security. It shows the ability to master complex, large-scale technological projects. This reactor is a cornerstone for a sustainable, powerful future for the entire region. Imagine a secret code that physics itself protects. That is the core promise of quantum technology. Unlike traditional encryption, which relies on complex math, quantum security depends on natural laws. These laws cannot be broken without detection. Any attempt to spy on the data changes its state. The system alerts users at once. This makes quantum communication one of the most secure methods ever designed. For years, this idea lived inside research labs. Scientists ran tests under strict conditions. Equipment was large, fragile, and costly. Many believed practical use was decades away. That view is now changing. A major turning point came with a historic satellite launch. The mission demonstrated secure quantum communication across vast distances. Encrypted signals traveled between ground stations thousands of kilometers apart. The experiment proved that quantum links could work beyond fiber networks and national borders. This success shifted global attention. It showed that quantum systems could function in real-world conditions. Space-based platforms solved a key problem. On Earth, quantum signals weaken over long fiber cables. In space, photons travel with far less loss. The satellite acted as a trusted relay. It distributed encryption keys with unmatched security. This achievement marked a major step forward for global communications. With the concept proven, the focus has changed. The goal is no longer, can it work? The new question is, can it scale? Engineers are now working to shrink quantum systems. Large optical tables are giving way to compact designs. Bulky detectors are being replaced by integrated components. The aim is simple: make quantum security usable for everyday devices. At the center of this effort are quantum chips. These tiny components perform tasks once handled by entire rooms of equipment. They generate and measure quantum states with extreme precision. They can be embedded into phones, laptops, servers, and network hardware. This miniaturization is a critical leap. It turns quantum communication from a national project into a consumer-ready technology. These chips protect data in a unique way. They use single particles of light to carry encryption keys. If a hacker tries to intercept the signal, the particles change. This disturbance reveals the attack. Unlike passwords or keys stored in memory, quantum keys cannot be copied. Security becomes a physical fact, not a software feature. The shift from theory to product reflects strong research and development depth. It requires expertise in physics, materials, science, chip design, and manufacturing. It also demands tight coordination between universities, labs, and industry. This pipeline shows maturity in advanced technology development. It moves discoveries from journals into real tools. The timing matters. The world faces rising cyber threats. Data breaches affect banks, hospitals, and governments. Future computers may crack today's encryption with ease. Quantum security offers protection against both current and future attacks. It prepares systems for the age of quantum computing. This progress places the nation in a strong strategic position. It shapes global standards for next-generation security. It opens new markets in finance, defense, and cloud services. It also strengthens digital trust, which modern economies depend on. This is a quiet transformation. There are no dramatic headlines or visible structures. Yet its impact runs deep. By turning quantum physics into practical protection, this effort signals a major China innovation breakthrough. It marks the start of a new era where data safety rests on the laws of nature themselves. Artificial intelligence is incredibly powerful. It is also incredibly hungry for electricity. The boom in AI computing is creating a massive ripple effect. It is fueling a surging demand for specialized energy gear. Hundreds of large data centers now dot the landscape. They all need immense, reliable power. This need is driving innovation in power supply and cooling systems. Companies are racing to build more efficient transformers and generators. The growth of AI is not just about software. It is fundamentally reshaping the industrial hardware sector. This link between digital brains and physical power grids is a key economic story. It shows how one technological leap forces progress in another. Get ready for rail travel that feels like flight. The latest high-speed train model is an engineering marvel. Its target speed is a blurring 400 kilometers per hour. Designers did not just tweak an old model, they started from a blank page. They blended new materials with aerodynamic breakthroughs. Every component was rethought for less friction and more comfort. This project pushes the very limits of ground transportation. It will shrink travel times between major cities dramatically. It symbolizes a national ambition to lead in high-tech infrastructure. This train is more than steel and circuits. It is a statement about the future of connected, efficient living. The age of humanoid robots has arrived. These machines have moved beyond science fiction and entered daily industrial use. On modern factory floors, robots with 2 arms, hands, and a human-like torso now perform tasks once reserved for skilled workers. They assemble tiny electronic components, tighten screws with exact force, and move heavy automotive parts with steady control. Their design allows them to operate tools built for human use, which removes the need to redesign entire production lines. Manufacturers deploy these robots in areas that expose people to risk or strain. They work in high heat, handle sharp materials, and repeat the same motion for hours without fatigue. A senior product designer highlights their key strength. Humanoid robots thrive in dangerous and repetitive roles. They reduce injury rates while keeping outputs stable and predictable. This makes them a strong fit for electronics, automotive, and metal processing plants. Adoption is accelerating at a striking pace. More than 100 domestic firms now design and produce humanoid robots. Startups and established manufacturers both compete in this growing field. Orders arrive daily from factories seeking flexible automation. Many buyers view these machines as a long-term solution to labor shortages and rising costs. Unlike fixed industrial robots, humanoids adapt to changing tasks with software updates rather than new hardware. This shift marks a turning point in manufacturing. For decades, industrial robots belonged only to massive factories. High costs and complex systems kept them out of reach for smaller producers. That reality has changed. Today, small and mid-sized workshops are adding intelligent robotic helpers to their floors. These businesses do not invest in full automation lines. Those systems remain expensive and rigid. Instead, they choose compact autonomous robots built for shared workspaces. These robots do not replace human teams, they support them. A mobile unit may deliver tools, move parts between stations, or carry finished items to storage. Others assist with loading, sorting, or inspection. By taking over support tasks, robots free workers to focus on skilled operations. Output rises without expanding headcount. Workflows become smoother and more predictable. The pace of adoption is striking. It exceeds that of other major economies by a wide margin. Millions of robots already operate in small factories across the country. This growth reflects more than policy or capital. It shows a bottom-up embrace of technology at the workshop level. Owners see direct gains in efficiency, safety, and consistency. Ease of use drives this shift. These robots learn tasks through simple programming or guided motion. Workers can set routes and actions in minutes. No advanced engineering background is required. Built-in sensors detect people and obstacles, which allows safe, close interaction. Robots stop or slow instantly when conditions change. Flexibility adds further value. A robot can move materials in the morning and support packaging in the afternoon. Software updates unlock new roles without new equipment. Small manufacturers gain speed, stable quality, and faster response to orders. This quiet transformation strengthens the entire industrial chain. It upgrades production from the ground up. The world's workshop evolves without noise, yet with lasting impact. Teaching a robot to prepare a simple cup of tea demands thousands of repeated actions. Each attempt records movement, timing, pressure, and error correction. Together, these trials form a large body of training data. That data now carries clear economic value. A landmark transaction has confirmed this shift. One company recently sold thousands of hours of robot training data to another firm. Reports describe it as the country's first commercial trade of this kind. This deal signals a new stage in industrial development. Robot intelligence no longer depends only on hardware or algorithms. The learning material itself has become a tradable product. Training data now stands alongside equipment and software as a core industrial asset. By placing a market value on data, the industry recognizes learning experience as a form of capital. The impact spreads quickly across the sector. Companies that buy high-quality datasets avoid years of basic training. They can deploy capable machines faster and at lower cost. Smaller firms gain access to advanced learning foundations once limited to large labs. This lowers entry barriers and widens participation in robotics development. Standardized datasets also improve efficiency. Developers focus on refinement and task optimization rather than teaching basic motions from scratch. As shared datasets grow richer and more diverse, robot performance becomes more stable and accurate. Quality rises through comparison, validation, and reuse. Data sharing also shortens testing and deployment cycles. Engineers test new models against proven data instead of repeating the same trials. Updates move from simulation to factory floors with greater speed. Robot intelligence advances through reuse rather than repetition. This shift creates a new digital economy niche. It transforms experience into a product and learning into an industry.